Hello everyone. In today's video, I'm going to go through the 7.3 homework sheet, specifically problems number 2 and 3. I already made a video over the first one about the Delta Math assignment. I don't remember if I showed this in the video, so I'm going to talk about it just briefly. But on the sheet, I tell you what it's called and the options you're going to choose on the screen, because there are 5 total, but only 3 of them that you'll actually use. The other 2 that are listed are throwaway answers. They're distractions, so you need to ignore them. Choose only one of these 3. Okay, so today we are talking about number 2 on the front. I'm going to do the top 2 problems. There are 4 others you need to complete, and then I will do one of them on the back for number 3. I'm going to do this one on the right. Also, something to note, if you got this copy from me the very first day I did it in class, then you have ABE for all of these statements here. If you want to go ahead and pause the video so you can get those changed, I'm going to flip this over so you can see the problems on the back real quick. Here are the back 2 as well, so make sure you get those changed. Okay, I'm going to flip it back over. So, number 2, the directions. These are all examples of AA similarity. So I am telling you these are all similar triangles and they're all similar by AA. These pictures, as you can see, I'm sure most of you would look at them and at first glance say, well, there's no way that they can be similar because there are no numbers. They are similar because there are angle relationships here that we need to discuss. Outside of that, obviously you'll want some numbers, but these are special cases. So, for these, you're going to do 2 things. First, you're going to mark with angle or curve symbols, however you call them, which angles are congruent. Remember, it's AA similarity, so you only have to mark 2 of the 3 pairs, but if you want to mark all 3, that's fine. And then complete the similarity statement. That's this part here. We have the first triangle name given. The second one we'll have to write in ourselves. So like I said, I'll do these 2. Once I've done both of these, you should be able to do any other type of problem that looks like these, because there's not many ways to change it besides just changing the size of the picture or the way it's oriented. So this first one here, we call a bow tie problem. I hope you can see why, but they connect at an angle. And when we have a bow tie problem, the first pair of congruent angles are at E right here. Hopefully you remember what this type of angles is called. If you don't, they are called vertical angles. Remember, that's where you have an X and then the opposite angles are congruent. So there's one congruent pair of angles. I just have to point out one more. To point out the other, I will have to revisit something from Unit 3. So, let me actually show you the angles that I'm talking about first. If you remember from Unit 3, we worked with this pair of parallel lines cut by a transversal, and it created 8 angles here in different relationships, specifically this relationship here between 1 and 2. Do you remember what it was called? If you said alternate interior angles, you would be correct. Remember, they are inside the pair of lines, and then they're on opposite sides of the transversal, making them alternate interiors. So I'm going to make my picture here look a little bit more similar. So if it helps, you can take the 2 parallel sides and you can extend them out to make those long lines you're used to seeing. And then the other thing you can do, because I'm used to it looking like this, I'm going to turn it so it looks a little more familiar. From here, I'm going to do my best to visualize this, because there is quite a bit going on. Whoops. If I cover up as much of the picture as I can, hopefully you see I've got my pair of parallel lines here, and then you can treat BC as the transversal. When we do that, B and C are the pair of congruent alternate interior angles. Hopefully you can see this angle's on the left side of the line and then this angle's on the right. So they're alternate and they're inside the blue parallel lines, so they are interior. And we can repeat that on the other side with A and D. So let me cover up what I can here. Again, we've got our parallel lines, and then if we look at A and D, those are also congruent. So, just to reiterate, we've got our transversal here. A is on the right side of the line or above it, however you want to see it. Then D is below it or on the left side. So then these are alternates and they're inside the blue lines, making them alternate interior. So that is how you find all three pairs of congruent angles. Reminder, you only have to point out two to fully show that this is AA. Just a quick kind of reminder, explanation, if you will. Oh no, I don't know why I did that. Oh, no, it's fine. Sorry, my eyes are playing tricks on me. Ignore me. Okay, so what I was going to say, in case you forgot, just need a refresher on the angle symbols themselves. I'm going to talk about those for just a moment because I did get questions on them. So with the angle symbols, you'll notice that each time I drew them in, I added a band, a curve, each time I went to a new pair. That's to distinguish between the different pairs of congruent angles. So for instance, these two in the middle only have one. And then when I marked B and C, I added a second band to make them two each. The reason I did that is so I can understand that these are congruent angles and these are congruent angles, but B and E, for instance, are not congruent angles. They're different from each other. If I use the same symbol for all the angles, that means they're all congruent. So each time I look at a new pair of congruent angles, I have to add an extra band, and I could keep going with it as much as I wanted to. So I just want to clarify on that. Okay, fill in our statement. We have triangle ABE is similar to, if you're not sure how to do this, match up the symbols. So which angle is congruent to A? D. Then we go A to B. So then we go to the angle that has two bands on it. So we go from D to C. At this point, there's only one other letter, so obviously it's E. They do meet at E, which has another pair of congruent angles. So that's the bow tie type of problem. There are two more. There's this one here, and there's one on the back. Again, we've changed the way it's oriented, but the problems themselves are the same. While I've got you on here for that, I'm going to mark which sides are parallel. That's something I should have done before giving you guys the final copy and forgot. So these two are parallel, and on the back, these two are parallel. Didn't want to forget that. I'll go ahead and have you fill in the other problems too, just to be sure that I don't forget. So these are parallel in this problem, and then back to the front side, these two are parallel. All right, let's do the other problem, this one here. This type we refer to as a nested pair of triangles, meaning one small triangle is inside a larger triangle. This one's handled differently. So I'll go ahead and tell you which angles are congruent. Q is congruent to N, and R is congruent to O. By the way, these are your congruent sides here, QR and NO. Let's take a look back at Unit 3 for another moment. This time I'm looking at these two angles here, for instance. Do you remember what these were called? These are corresponding angles, meaning they're in the same spot, same position, however you want to see that. So these two here on my example are in the top left corner. If we look at our picture, and again, if it helps to draw those lines out, do that. If it doesn't help, then don't draw it. For me personally, this was helpful. Both as a student and actually now. I still do this sometimes. Hopefully your lines are straighter than mine. So again, if I cover up half the picture, maybe this will make it a bit more obvious to you. Okay, try to tilt it so it's going the same direction. So, if you look at Q and N here, they're both in that top right spot here, in the same spot, therefore they're corresponding. And then if I look at the other side, this one actually looks just like the example I drew here. They're both in the top left position here. Another way you can look at these angles without using the transversal cut by, or transversal cutting a pair of parallel lines. So remember, these triangles are similar. So if all I would need to do is change the size of one of them to get the other. So I'd have to make this triangle larger so it fits this triangle, if they're similar. That's what that means. They're proportional. So imagine if I take this side, QR, and I pull it down so that it's on top of this one, creating the big triangle. Angles Q and R would have to end up on top of N and O. So these two would have to be the same as these two if I were to try and change this size and make it bigger. So that's just another reason why the two angles that are on top of each other are going to be congruent. Lastly, let's finish naming. We have RQP. So then naming the second triangle, we're going to go with the large one. R is congruent to O, so that has to go first. Q is congruent to N, that has to go second. And then in this triangle, they actually share P. P is in both the small and the large triangle, so P goes at the end again. Since this P is the same P for both triangles, literally the exact same P, then this angle is actually congruent to itself. It's kind of interesting. So that's our statement, and that is all. These are the examples I'm doing for this section, for section 2. You have 4 more, 2 of each, that you have to do on your own. Remember, they're all done like one of these two. So figure out, do you have a bow tie or do you have a nested triangle problem? And then you will use that example to solve it. And if you want to write the names down, if that helps. This is the bow tie problem. And then we call this the nested triangle problem, or nested triangles. All right, on to the back. Number 3. I'm going to do the second one here. This one's actually pretty easy. Once you see how to do it, you'll understand why this one's actually easier than the other 3. So I want to do number 2, or the second problem, if you will. I guess you read the directions first. For each problem, set up a proportion and solve for x. I want you to pay close attention to how I do this, because this is one of the most missed problems on the test. When I remember, think back to last year, this was easily top 3, maybe even top 2. A lot of people struggled with these problems. When you have one triangle inside of another triangle, you need to redraw it so that they are 2 separate triangles, one small triangle and one big triangle. So in this space here, I'm going to redraw those. Try to draw it as best as you can, but I know that some people are better drawers than others, and it's okay. But the more that this looks like the original, the better. So here's my small triangle. I'm going to draw another one, but much larger. And if you can draw really good pictures too, it just makes you believe it more. Convinces you better. So something like that. Next, and this takes a bit of time because you want to be careful with it. You don't want to mess anything up. I'm going to fill in the letters that go with each triangle. So for the small one, this one up top, the bottom left letter is E, the top letter is D, and the bottom right letter is F. Then I'm doing the large one. Bottom left letter is B, top letter is D, bottom right is C. So make sure you understand where the letters go. From here, I'm going to fill in the information they did give us. So I'm going to start with the 10.5. 10.5 is DE. That's in the small triangle. It's this side here. Then we have EF, which is 9. That's this here. Now let's go to the big triangle. I have X, which is on BC. This last side I'm about to fill in is where the mistakes are made. So hopefully by looking at it, you can tell that you're going to make a proportion using these sides, and we're just missing BD. A lot of people might think to put 7. Remember, this side is B all the way to D, not B to E, B to D. How long is this side? Well, they tell us this section is 7, and this section is 10.5, so let's add these. So we have 7 plus 10.5 equals 17.5. that's the number I'm going to use for this side. Not 7, not 10.5, but add them together. 17.5. So that's the setup. So again, takes a minute or two to do that. Make sure you do it. Make sure you're careful about it. Make sure everything's in the right place. From there, it makes setting up the proportion easier. So setting up the proportion. Got my two fractions here that I fill everything in. I recommend you start with the x, because you can really start with any number, and I think sometimes when you have too many choices, it actually becomes harder. So always start with the x. Put x in first. From here, the rest of it falls into place. The number that has to go under x is going to be the same side, but the other triangle, so 9. That's why I also like to draw them positioned the same way, so it's like a mirror, if you will. Not a mirror, but you know what I mean. Like a replica. So 9 and x, same spot. So x over 9. Then I have 17.5 and 10.5. But the one has to go on top, the other has to go on bottom. If I flip them, my answer will be wrong. So I have to put in the top a number that is in the same triangle as x. Here my only option is 17.5. So they are in the same triangle, so they have to go next to each other. And then again, x and 9 are the same side, just different triangles. So they go together. X basically has to have something in common with the thing that's next to it and under it. So that leaves 10.5 here. 10.5, it's in a different triangle from x, and it's not on the same side. Like 10.5 and x are completely different. That's why they're across from each other. Once you have that set up, hopefully you know what to do from there. We cross multiply. So I'm going to try and find another color here. We'll see how well this shows up. I think it'll work. So remember, you just cross multiply. 10.5 times x leaves you 10.5x equals 17.5 times 9. And I actually need to do that with my calculator. I don't know what that is off the top of my head. 17.5 times 9. 157.5. Do not round. Keep that number. So there's my equation. Then you solve like normal. So we're going to divide 10.5 on both sides to get x by itself. And then bring down the x. This cancels. Going to divide this by 10.5. And that gives me 15. X equals 15. And that is it. That is the correct answer. The other three problems are done in a very similar fashion. I will go ahead and point out something about number 1. So a lot of people didn't realize this. In number 1, they give you that RS, the whole side is 27. So that's what this is pointing at. So what a lot of people are doing is adding 27 and 15 together. You don't need to do that. The large triangle here, because you got the small one, this side's 15, so on the large one it's 27. So you actually don't need to add or do anything extra. You have all the numbers you need. But the other two are going to be like the one we just did, where you need to add these together to get your long side. So just be mindful of that. Again, redraw the triangles, label everything. This seems to be really helping, so I hope this helps you too. If you have any additional questions about the video, about the material, anything like that, feel free to reach out to me either via email or when you see me in person. Otherwise, you have a wonderful day. Bye!